Hi everyone. In this video, you will learn everything you need to know about Docker volumes, what they are, how they work, and how to use them in real world projects. We are going to cover everything from scratch. So whether you are a developer, DevOps engineer, or just starting out with Docker, this video is perfect for anyone looking to learn Docker volume from scratch. So let us first understand what is a Docker volume. So Docker volume is a persistent storage managed by the Docker that allows data to be stored and shared between containers and the host system. Here, one thing you need to understand is that like Docker volume, we create outside of all the containers, and it is managed by the Docker, and we can persist the data within the volume which is beyond the life cycle of the individual containers. Like even if we stop or remove any container, the data will not get lost because that is stored inside the volume, and volume is outside of all the containers. Now let us understand how Docker volume works. Like we know that Docker volume stores and manages data that is used by the Docker containers, and the data will get managed across container life cycles like container restarts, rebuilds, or deletions. Now, how we can create this Docker volume? Like while creating the container, we create the volume, and we can either use Docker volume create volume command or Docker compose command. With this, like Docker stores this volume in a designated folder on the host system within var lib docker, and inside that it will create some volume folder. Okay, inside that it will store the data, and basically the important thing is that it is outside of any container. Now, when restarting a container, we mount the volume using -v or --" mount command. With this command, it will mount the data from the container to the host file system inside the Docker area. Now, inside the container, we have a folder app/data, so which has a direct link to the volume. So, any file returned to this app.data is stored on the host system, because there is a direct link to this one. And we need to understand here like how container uses the volume. Like container reads or writes the data to this app.data, and this data goes directly into the volume on the host system and not in the container's own file system. So one thing you need to understand, whatever the data or file write we do at this, that will get stored on the volume, due to which like even we delete any container, running container, we can access the volume data which is persisted inside the volume. Now next, there are some key points we need to understand while understanding the Docker volume. Like it persists data independent of a container lifecycle. So as we have seen, that is like even after the container lifecycle, when we restart any container, we can access the data state which was there earlier. Now, and it stores on the host system, but it managed by the Docker. So next thing, like whatever the Docker volume data is created outside of the container is managed by the Docker itself, and it can be shared across containers. And it will also support backups, migrations, and inspection. So these are some notable points we need to understand while understanding the Docker volume. Now to understand Docker volume thoroughly, we need to understand it with some practical examples. Now here I am going to cover two scenarios. Like in first scenario, I am going to create one application without using the Docker volume. So in this case, I will create one Spring Boot application using latest technologies like Java 21 and Spring Boot version 3, and we are going to use PostgreSQL as a database to store the data. Now here we can create the Spring Boot 3 application. We can create one Docker file inside that, and after that we can create one Docker compose file, and inside that we will not mention any Docker volume, and we can run the Docker compose to create the Docker containers for this Spring Boot application. And once we run the container, we can persist some data inside our PostgreSQL database, and next we can stop the container and remove the container running instances, and next we can restart the container and check whether we can access the similar state of data which was there earlier. So we will find that we have lost the data because we have not used a Docker volume at here. Now this is the first case scenario. In next case scenario, we are going to include the Docker volume inside the Docker Compose file, so that we can utilize the Docker volume mechanism which will store or persist data outside of all the containers. Now here we will use the same Spring Boot application, only this time we have included Docker volume inside the Docker Compose, so that we can make use of this Docker volume. Now we will run the Docker Compose here again and create the containers and run the containers, and we will store some data inside the PostgreSQL database, and after that we can stop and remove the container once again, and we will restart the container, and this time we can see that we can access the state of data which was earlier there. Like we can access all the entries we have persisted and which we have stored inside the PostgreSQL database. So this time, as we are using the Docker volume, we can access all the data which we have stored earlier. This way we can access the data which was there inside the Docker volume by any container which is running, or by we can access it by any other container. So I will request you all, so before we start with the practical examples, please do not forget to like, subscribe and share. I need your support to grow my channel. Now let us create our first scenario in which we are not going to use Docker volume. So here we can copy this parent folder wherein we are going to create our application. Now let us open our Spring Tool suite, which is at here, and here we can paste this folder and we can launch it. Now here we can close this. Now here we can choose the third option to create a Spring Boot project, and here we can mention our project name. Let's say it's a user-service, and here we can choose the build type as a Maven. Java version we can select 21, and here we can add com.user. Rest of the things we can keep as is, and here we can say it's a user project for Spring Boot. Now here for package we can use com.user. Now this much is enough. You can cross check it once, and once everything is fine, you can click on next button. Now on this next page we need to add the dependency for our project. Like we can first add a Spring Web dependency to create REST controller and to create rest of the stereotypes. Next we can add Spring Data JPA. Next we are going to use PostgreSQL database, so we need to add this. Next we are going to use Lombac, so this is the dependency for that one, and I think this much is enough for our application. So we can click on next, click on finish. Now we can see here we have successfully created our user service with all the dependencies. We can cross check it once, like we have all these dependency. Fine. Now next thing, here it is showing some reads, so let us resolve that by adding HTTPS at the place of HTTP, and we can save it. Now let us create our application.yaml file. So for that we can remove this default application.properties file, and we can create one new file with name application.yaml. So you can use application.properties or application.yaml file, either will do fine. Now let us add some port number at here, and we can give any port, let's say 8087. So before we add this, let me change the font so that it will look good. So let me use increase the font by going it here, and this is the text font. We can edit and we can choose 14, apply and close. Okay, seems good. Now it is fine. Next thing, we can use our application name. What application we are going to use? Spring.application.name, and here we can use application name as a user service. And next we can use data source. For that we can add URL, and for this URL we can use JDBC colon like PostgreSQL colon. Now here if we are using our host system database like PostgreSQL, we can use we used to use like localhost, and after that we can use 5432, which is our PostgreSQL port number, and after that we used to give the database name like user-db. But now we want to run the container service, PostgreSQL container service. So for that, here we should not use the localhost, it should be db, because this service we are going to mention inside the Docker compose with name db, and our application will use this PostgreSQL service with name db. Now next we can add our username, and we can add some username, let's say PostgreSQL or Postgres. Next we can add some password. So whatever username you have set, so you can use it, and here I can give some password. Next we can use JPA, and there is a Hibernate properties. After that we can use DDL as an DDL-ATO as an update. So let us give some space, otherwise it will show error. Fine. So this is the update. Next thing we can use show SQL, and for this we can use as a true, so that it will show the executed queries on the console. And finally we can add our database platform. And as we are going to use the PostgreSQL database, so similar dialect we need to use it here. So we can use org.hibernate.dialect, and here we can use our database specific dialect name, which is PostgreSQL dialect. That's it. We can save it. Now we can do one more thing. There are indentation issues or errors, we need to resolve that. So for that we can create one, we can copy it and paste it here, and we can replace the every occurrences of tab with some 2 spaces. Okay, so we can replace it so that it will be in sync and it will be in formatted. We can copy it. Now here we can paste it. If we want, you can resolve it, we can resolve it one by one, but it will take time. So rather I have replaced every occurrences of tab with 2 spaces, and we can paste it. Now there is no error, so we can remove this. Fine, seems good, and we can save it. With this we are done with our application.yaml file. Now next thing, we need to create the respective packages. So let me create first package, which is the entity. Next we can create our repository package. Next we can create our service package. Next we can create controller package, and this much is enough. Now let us create our entity class with name like, let's say, user details, and here we can add respective annotations like all our constructors, no our constructors, @builder, and here we can use @entity, which is the important annotation we need to use. And for this we can add @data annotation, and we can add import for that. Now next we need to define what all properties we are going to use for this. First is a long id. Next we can use private string name. Next we can use private string email, and Next we can use private string role. So this much is enough, and we can create the getter setters using this one, and we can select all and generate. So we have created the entity class successfully with all these attributes and using these annotations, and these are some getter setters. Fine. And now we can save our changes. Make sure you are saving every modification or changes of the file. Next we can create our repository part. For that we can create an interface and we can name it like user repository, and for this we can add respective stereotype with name repository, and it should extend either JPA repository we can use or CRUD repository we can use. So here we can use JPA repository, and here our entity class name which is a user details, and the data type of the ID which is a long, and we can save it. So we have successfully created one repository. Next we can create one service interface with name like user -service, and here we can mention what all methods we are going to call inside that. Now the first method is for getting all the user details or list of users. So we can say this is the user details, and we can say get all users. This is the first method. We can add import, and next method we can use like for creating a new user. So we can say create user, and inside that we can add a new user to be created. That's it. So this is about interface, and these are two methods which we are going to use. Now let us create one implementer class which will provide all the implementation for the methods which are available inside the interface. So we can name it like user service IMPL, and we can add respective stereotype of service, and here it should implement user service interface. We can add all the imports. We can provide the unimplemented methods implementation at here, and the next thing here we can inject our user repository, so that we can call respective methods which are available on this repository. So here, and we need to annotate it using @wide. Now here we can define one public constructor at here to initialize this repository. And here we can use this dot user repository, and we can assign this. Now next thing, we can provide the actual implementation for these two methods, like we can call respective method which is available on the user repository like find all. Okay, so here we need to add a return statement. Seems good. Now similar way here we need to provide call the respective method which is there in the repository. So we can save this new user into the PostgreSQL database. Seems good. We have provided implementation inside this service implementer class for the methods which are there inside the user service interface. Now next thing, we can create our controller. We can save it, and this is our controller wherein we can create our user controller class, and we can annotate it using REST controller, and we can auto-wire using our service which is user service. Next, we can create one get mapping. And here we can provide our users annotation endpoint, and here it will return list of user details, and we can name it like get all users. We do not need to pass any input params, and here we can call respective method on the service. So that's it. We have created one endpoint successfully. Similar way, we can create one more endpoint. So here, if we want, we can add a response entity, which looks better, and we can wrap the return type inside that. And here we can return a response entity.ok. So it has status as well, which we can make use of. So similar way, we can use a response entity it here, because this is the post method we are going to implement it here, which will return the individual user object which we have inserted into the database. And here we can use create user. Now for creating user, we need to add request body, and for that we can pass the input user details, which is a new user we are going to insert into the database. Now here we can call the respective method which is available on the service. So create user, and this is the new user. Now we can add imports for all these, and here we can add response entity.ok. So if you don't find any step in between, so I'm going to provide the code link details in our video description, so do not worry about that. So we have successfully created 2 endpoints. Now we can save it. The coding part we are done with. Now next thing we can do, like first we can build it and check how it goes. You can use this run as maven install command. Now there is one test failure, so we can open the test, and for now we can comment out all the test and we can save it. Now let us build it again. Yes, it's a build success. Now let us do one thing, like let me cross check the application.yaml file, how we have defined seems good. User DB will get created. Now next thing, we can create our Dockerfile inside the root level. So for that we can right click and new, and this is the file, and we can give Dockerfile with no extension. And here we can mention what all things like container definition, we need to mention it here, like we can define it here. We need to mention what JDK we are going to use. So for that we can use open JDK. Now while adding this entry, we need to make sure what JDK Java version we are using, and here I will show you. This is the Java version 21 and Spring Boot version 3.5 we are using. Now inside Dockerfile we need to use compatible Java version because we are using 21 JDK 21, so we can use we need to use open JDK. This is the 21 and JDK hyphen slim. So this is the compatible for our Java version 21 we need to use. So next thing we need to use we need to set working directory, and here we can use work dir. After that we can use our user service or our application name. Next we need to declare some arguments like build arguments, we can say. For that we can declare argument like jar hyphen file, and here we can use target /star.jar. This is the build arguments we can use. Next we can use copy command, copy jar into our image. So for that here we can mention this is the copy, and what we are going to copy, it's a jar file, and where we are going to copy into user hyphen service dot jar. User service hyphen dot jar. Next thing we need to mention the expose for port. We need to expose the port, and here we can use port number, and what is the port number we are using, that we need to expose, and here we are using 8087, same port, we need to use it here. Next thing we need to run our application. For that we can use entry point, and here executable we can use Java. Next we can use command hyphen jar, and what is our service name, like user hyphen service dot jar we can use. So this jar will get created with this command. This is about our Docker file we have created. Now let me tell you one by one what we are going to achieve. Like as you know that we are going to use JDK 21, so Java 21, so the compatible Java image, JDK 21 image we need to download. Next thing, like we need to define work directory, which is a user service. Next we need to define build arguments inside jar file. It should take the jar file which is there inside the target folder. Now if we check inside target, we have created the jar file. Next thing, we need to copy the jar into the image. For that we can use this statement, and next we need to expose our port, which is 8087. If you want to check the port, you can open the application.yaml, and this is the port name. Okay. Now and finally we are running our application with this command. This is the Java interpreter, this is the -jar command, and this will create a user service.jar file. So this much is enough for the Docker file we have successfully created. We need to build it again so that it will use the Docker file as well. Seems good, it's a build success. Now next thing we need to do, like we need to define one Docker compose file, and then we can run the containers. So for that, what we can do, we need to go at the location, the folder where our application is, this is our application folder. Now at this level we need to create, because we are Docker compose, we need to create above our application project. Like it should not be inside our project. We should not create the Docker compose file inside that. Rather it is we are going to create multiple container applications. That's why it should be outside of any application. So here what we can do, we can copy one application.yaml file, So which is it here, we can copy. Now we can go, this is our user service, and here we can paste it. Now we can rename it. This is the YAML file, so we can rename it with Docker Compose. Okay, so anyway it is a YAML file. Now we have Docker Compose. Now what we can do, we can open it with Notepad++, and here we can remove everything which is inside there. We have copied. Now let us make some entry for this Docker Compose file. So we can add services, and for the services we can use, like, what is our service? Is a user service. Next we are going to mention the build, and what is the build? Inside that we are going to add contest, and for contest we are going to use our application name, which is the user service. Now this is the contest, like where this is the contest like which our Docker Compose will refer. So at this contest level, the Docker Compose will find our Dockerfile, and inside Dockerfile we have defined how the Docker Compose should create the Docker container. Okay, and it's a Docker engine which will create the Docker Compose, but Docker Compose will refer our Dockerfile which is at the contest level to create the Docker container, because Dockerfile will contain the Docker definition. So this is about build. Now next we can add Dockerfile. Okay, so here we are going to mention our Dockerfile as is, because it is going to referred by our Docker Compose. Okay, fine. Next thing we can add, sorry, it should be there should not be any spelling case related, case sensitive issues, so we can add as is. Next we can add ports, and what is the port name we are going to use? In our case it's 8087, so same we can use. Now here first is a host port and second is a container port. Okay, so these are this is the variation, because that's why we have taken two ports. Next we need to mention depends on, like there is no dependency, so depends on we need to use, because it's a depends on our PostgreSQL database. Okay, so we need to use that, and here we can mention our PostgreSQL service with name DB, and here we can mention environments. So it should be environment, and for environment we can add Spring, profiles, and active. It should be default. Next we can use our, at the environment level we can use our restart, which is always. That's it. Next thing we can mention our exact DB which is at our user service level. So here we can check the alignment. Now here we can mention the DB, which is the PostgreSQL service we are going to create the image for, and we can say it's a Postgres, and this is the 15 we can use. Next we can add environment, and for that we can mention Postgres DB, and here what is the database name we are going to create? It's a user-db. Next we can use Postgres user, and what is the user we can use? Let me add one user. User we can add, like, let me add Postgres, and for password we can copy this, and for password we can add our respective password. Fine. Next thing, we can mention what are the ports we are going to use. So which is for our database, which is 5432, which is the default port we can use. Next, we need to this much is enough, because we are in our first scenario we are not going to use any Docker volume, so we can save this much and check how it works. Now let us cross check it once if we have missed any. So this is the services, seems good. This is the database service, it depends on. Fine, everything seems good. Now let us save it, and next thing we need to create our containers. So for that we need to start our Docker desktop. And here is the containers. You can see there is no image and containers. Okay, now let us go to our folder. This is the folder, and at this level we can open the command prompt, and let us use our Docker commands. Like we can first use docker build -t, and what is our user -service. This is the tag -t for tag, and user service we want to create the image at the current level, so we can hit it. It should be docker build failed to sort Dockerfile, open Dockerfile, no such file or directory. Okay, so basically we need to go, like if we want to create the image, so we need to go at service level, and from that we can run our Docker build. But now we are going to use Docker Compose, so we need to build the images using command, like we can use docker up docker compose. So this is the compose we need to use, up build. Now it will create the image for us. So let us check what is the file name. We have used docker compose. Same we are using. Okay, and what is the file extension we have given? Seems good. -compose. Okay, so there is a at line number 8 there is some issue. It is showing. So this is the line number 8, and it depends on, after that this is the DB, and for this DB we have this environment. Okay, so basically this environment it at this level depends on, so accordingly we need to shift this, and we need to change it. Now it seems good. Now let us save it and check. If there is a indentation related error, so it will not work. So let me clear it first, and we can run the containers. Now we can use this docker compose of build. It will create the image, and it will create all the images which are necessary, and create the containers as well. It has started creating the image and containers, you can see. Now it will take some time because it needs to create the database service as well. You can see it is creating the DB service which is needed for our application. Here it will take a few minutes or a couple of minutes because it has some files, number of files it need to download. So till the time it completes the download, let me show you what it shows inside container. There is no container, there is no image inside our Docker desktop, and there is no volume as such. Okay. Now let us check. Once it completes, it will create the container and images for us for the application. Fine. Now, yes, it has completed successfully all the images, and it has run the containers. Now we can see the status of running the containers, and we can ensure that everything is fine. So there is some error. Let us check why it is not showing. Okay, so basically we need to add the ID annotation at code level. So which we have missed inside entity. So this is the entity we need to mention. This is the ID annotation we need to add, because it will basically tell how we are going to auto increment our ID, and we can say it's a generated value annotation, and we need to mention like what strategy we are going to use to generate the value. So for that we can use it's a generation type dot auto, and we can save it. Now we need to add annotation import for this, and we can save it. Now we have everything in place. What we can do, we need to build it again. Fine. Now if you go back to the container, here we can see it has created downloaded the PostgreSQL 15. It is the container for database is running, which is a DB service, and this is it has failed. So let me let me down our services or stop the services. I have stopped it. Or for stopping the services, you can use you can use this command, which is a docker -compose, and we can use stop. And it will stop all the containers which are running. Now if you check it here, it will stop all the containers. This is grade, Earlier it was showing green, but now it is showing the gray. That means it has stopped. Now let us remove the containers because we want to recreate it. So we can use the command which is down to remove the containers, and it has removed successfully all the containers. Now let us check. It has removed containers. Now here it has removed the containers. Now we have these are the images. Now what we can do, we can remove this image which is application image. We can remove this, and this is the PostgreSQL database image. Now we can keep as is, because if you check it here, like it will take much time to download the database image. So that's the reason we can keep the image as is, because it will take much time. So this is our database related files. It will take time to load this. So anyway, that is not going to change for anything. So we will keep as is. Now let us we have built it. Now next thing we can do, like here we can once again use that docker up build command, so that it will build the image and create the containers for us. Now it will not take much time because we have taken the PostgreSQL image, and yes, now this time we can see it should show like yes, we can see started user application. That means it has successfully started our user application. Now let us go back to the container and check. Now here we can see there are two images, one for database and one for our application, and here are two containers which are running, like db1, it's a database service, and this is our application service container. Okay, and we are using the Docker volume, so Docker compose, so that's why it is inside this application, which is our parent folder Docker volume. So we have created successfully two containers using the Docker compose. Now the important thing, like we need to test our application. So for that we can open the Postman, and here let us use our port number which is 8087, and here we can use our endpoint which is users. So if you want to cross check the endpoint, we can check it here. So this is the users. Okay, now we can use body, and here we can hit the send button and check. So here we can remove this slash which is not necessary. Now it is showing empty array, which is as expected because we do not have any data. We have not persisted or inserted any data as of now. So let us create one record, like one user to insert into the database, and for role we can add, let's say, admin role, and this is the Samir, Gmail for Samir, and here is a post method we can add. We can see one record we have successfully created. Let us add one more record for Kiran and email for Kiran, and here we can use like a role, it's a manager, and finally we can create one more record like a Robert, and this is the Gmail for Robert, and we can say its a role is a guest. Now we have successfully created 3 records. Okay, now what we can do, like we can check by calling the get method. It should show 3 rows, 3 users, and these are the 3 users we have successfully created into the PostgreSQL database. Now the point here is that how we can check whether the data is successfully inserted into the database side of the container. Now we are not using our database which is on the host system, rather we are using the database which is inside the container. Now to find the actual to locate the actual data is a challenging task, so let us see how we can do that or achieve that. Now let us go to our project folder once. This is our Docker Compose. Let me open one more command line, command prompt. Now from here, we need to check what are the processes running for the Docker. We can use Docker ps command and it will show us all the processes which are running. Now these are two processes, one is for the database and one is for the application. Now we need to go inside the container to check what data it has. Like for that, what we can do, we can go to our, we need to go inside the container. So what command we can use for that? We can use like so we can use Docker execute for executing it, it's IT, and here we can use our container ID or we can use our image name. So anything will do fine. So we want to access the data, so we need to go to data container. So for that reason we can paste this. Now not this, we need to copy the image and this much is enough, and after that we can use bash to insert go inside that. Now we have entered into the container. What next we can use, like to reach the database, first we can check if what all folders are available at there. Now let us go to like var, inside that we should be having the lib folder, and inside that we must be having the PostgreSQL database folder. Inside that we can access the data. Let us check, seems good. Now in this we cannot directly see the actual table name and the database name, unlike we see on our host system inside going through the database. So that is not the case at here. Now this is in the format of the binary data. Now to access the data from here, we need to use some PSSQL command, and here we can use our username, which is a Postgres, what we have mentioned, and here we can use our database name, which is user_db. Now we have come to the prompt 8 here, user database. Now here, from here we can use our select query like this one. I hope you can it is visible to you. Select star from, and here we can use our database, customer database. Okay, so basically we need to end it, select. It's not customer, it should be user database, right? So it should be user or user details. We need to, okay, user details, not user details. We can check with select, or what we can do, we can select star from user and details. Okay, basically we need to use select as a capital, star from, and our user. So this is the user details table we can access. So it's a user details. So let me check. It's a user. Yes, it is showing one row. Okay, actually it is taking the system user. So basically we want our user details. So let me check what is our entity name we have given. It should be user details. So same we can use it here. Now here we can see our table details, it is not showing. So what we can do, we can come out of our DB service and we can once again go inside that. Now this is our prompt database user DB. Now if you check our entity class, which is user details. Now in PostgreSQL it will create user underscore details table inside this user DB. So let us use that select query, select star from, and we can use our user underscore details table. Now we can see it is showing all the records which we have inserted. Now this way we can actually access the data by going inside the container, like this is the DB service container and we have gone inside that container and access the data. So this way we can check the data inside the container. Now next thing what we can do, we have some data we have stored. Now next thing we need to stop the services which are running, container services. So for that let me stop this. Yes, we have stopped. If you want you can run the command again, like stop. To stop we can use docker compose stop, or and to remove the containers we can use docker remove. Sorry, it should be docker. So for removing the container there is I think docker down command, docker compose down command. Yes, we can see it has removed all the containers. Now if you go back at here, we can see there is no container. Now once again we can restart our application and check how it will spin up the new containers. So for that we can reuse this build command, so which is docker compose up build. So it will recreate the restart the container again. Seems good, it has started our service inside the container. Now let us check, these are the container running. Now what we are going to check, like we have this data which we have persisted earlier into, stored earlier into the container, into our database service we have stored this data. Now we need to access this data through container, application container. So for that we can test it again and check whether it is showing this data or not. So let me hit the send button. Now we can see it has not persisted any data and it is not showing any data because we have not used any volume at this stage, due to which it has not persisted data outside of container. So once we delete the container we will lose the data, we have lost the data which we have stored earlier. So this is the completion of our first scenario wherein we have tested our application without Docker volume. Now we will test our second scenario in which we are going to mention the Docker volume. We are going to create the Docker volume and inside that we are going to persist our data. So let us do that. So for that what we can do, we simply need to add some entries inside the Docker because we are going to use the same application. So we will only make the changes inside our Docker compose file. So after this port we can use volume. Make sure you are using the you are not making any spelling mistake. And here we can use our database like let's say user PostgreSQL data we can use, and for that where it is like var lib PostgreSQL, and this is the data. So if we check So this is the data folder. We need to give it here for creating the volumes. And next what we can do, like its service level, we can add volumes and we can mention our volume, which is user pg hyphen data. So this is the volume we are going to use, and we can save it. So what we have done, like we have simply added one entry for volumes, and this is the volumes we are going to use in this case. Now we can save it. This is the Docker Compose file, and we have added entry for volumes. Now it will persist data out of all the containers, so that whenever we stop the container and restart it again, we can access what data we have stored. So let us test that. Now what we can do, we can check whether these are the containers running. So let me stop all the containers first. So we have stopped containers. Now next thing what we can do, we can remove the containers with using this command. Next thing, we can up container using this command. Now we can check. Now this time we are using the Docker volume. So our application is running fine. Now let us check. We have created the containers again. Now if we check it here, these are the images, and here we can see it has created our volume. Okay. Now let us hit the URLs endpoints again and check. So it is showing the empty data, because which is as expected, because we do not have any data. So let us add some data with username, and we can add username as a Kiran, email as a kiran@gmail.com, and next we can add role, which is, let's say, admin role we are going to add. Now let us use post method to insert the data into the database. We have successfully added one entry. Similar way we can add one entry for Shiv Kumar, and this is the Gmail for Shiv Kumar we can add, and let's say he is a manager. This is the second entry. Similar way we can add one more entry, which is for Vijay, and this is the email of Vijay, and we can say he is a guest as a role. Now we have successfully added 3 records. Now let me call the get method and see. Now we have 3 records which we have added. These are 3 different users we have added with some different roles. Now let us access this. Let us stop the containers and we can restart it. Okay. So for that, what we can do, like, let me stop it all. Yes, we can see we have stopped all the containers. Now let us remove the containers. Okay. We can use this command and it will remove all the containers. Now we can check. We do not have any container because we have just deleted all the containers. Seems good. Now what we can do, like we can once again restart the container. So why we are restarting the container? Because we have some data persisted inside volume. Now if we spin up the container again, okay, now let us check. Now it has created the container for us, like this is the application container and this is the DB service. Now let us hit the get endpoint again. Now once we hit the send button, it should show the data, because now we are using the volume, Docker volume, so which is outside of all the containers. So once we stop the container and restart this, it will retain the state. So let me hit the send button. Seems good. Now it is showing all the data which we have persisted before we close the container. And after we close the container and restarted, it is showing the same data which we have earlier added. This way we have completed both the scenarios, like how the data will be without Docker volume, and how the data state will be once we use the Docker volume. Okay, so both the scenarios we have successfully tested, and we have understood how we can use the Docker volume for our applications, and how it will maintain the data persistency out of the containers. Okay, and we can make use of that, we can access that data from any container. I hope you must have enjoyed this. Please do not forget to like, subscribe and share. Thank you so much for watching this. And I am going to add the code link in the video description. Please check that. If you face any issue, you can access the code directly from our GitHub URL. Thank you so much for watching this.